part 3. Make this focus a little bit. All right, part 3, we have potential energy. Which we abbreviate as PE. Okay, this is any type of stored energy. So stored energy, whether that be in chemical bonds, so like, for example, if you eat lunch and your food is digesting, that you are creating chemical potential energy, or if a roller coaster is at the top of a hill, it will have potential energy. So it's stored energy due to a variety of things. So it's due to its position, its condition, okay, or chemical composition. Okay, so our potential energy is stored energy. I would say that the position is probably the one that most kids are familiar with. So that would be, again, like the roller coaster example, or if you're sledding and you're at the top of a hill, you're going to have a lot of potential energy, whereas at the bottom of the hill, you're going to have less potential energy. So we're going to go over the 4 types. So there are 4 types of potential energy. So we're just going to go through them pretty quickly. So the number 1 that most people think of is gravitational potential energy. So what that means is it's based on how far above the ground you are. So I'm going to Jones note this to make it a little more simple, but it's just how far above the ground. So an example would be if you were going to go skydiving, or you're going to roll a ball down a hill, okay, etc. So those are just some examples of gravitational potential, which is usually the most common one, and that's usually the one we would actually calculate. So you'll see that when we get to the formula part. Number 2 is elastic potential energy. So what that means is it's when something is either stretched or compressed. So what that means is if you think of like, for example, a hair tie or something that's made of elastic material. So here's a hair tie. If I pull it, I'm increasing its elastic potential energy, but when it's here and it's not getting stretched, it doesn't have a whole lot of elastic potential energy. So for example, obviously that hair tie, a trampoline, a spring. So like sometimes you'll have springs in like your bike or something. So that's when it's stretched or compressed. So that would be elastic potential. Another one that is a main type is chemical potential energy. So what that means is that it has to do with the chemical bonds. So those would be the bonds in like food or different things like that. So some prime examples would be photosynthesis. If you are eating, that would be like digesting more. Your food is going to break it up and give you that chemical potential energy. A battery is stored chemical potential. So when you have your remote for your TV, the batteries inside will give your remote the chemical potential energy it needs to operate. And then the 4th one is mechanical potential energy. Now this one's a little bit kind of confusing, but it's based on the object's position in general. Okay, this one and gravitational usually get a little confusing. So it's basically the potential to move. So I'm going to explain this more in a second. So it's the potential to move. So for example, this would be like if your pen is on the edge of your desk. It has the potential to fall, but gravity is not acting on it yet. So a lot of times when you think of the roller coaster example, when the roller coaster is at the top of the hill, okay, so I'll draw this to help you. If the roller coaster is here, it's mechanical potential. It has the potential to go down the hill, but gravity technically isn't acting on it yet. Once it moves to about here, then this is where you would get your GPE more. Gravity's acting on it. So when it has the potential to fall or move, it's mechanical. And as soon as it starts to actually get pulled by gravity, it converts into gravitational potential. So that's a little bit of a confusing one. So those are the 4 types. So now we're going to get into the formula. So the formula for GPE, and I'm going to show you GPE because that's the one we usually calculate. We don't really typically calculate how much chemical or elastic, or really even mechanical, but once it starts getting pulled by gravity, we start to really focus in on calculating that as scientists. So we do GPE, so gravitational potential energy, is equal to the mass of the object, so it depends on its mass, okay, times the gravity, which we discussed actually in our gravity lesson, so we're going to talk about that in a second, times the height. So the height and the mass are the 2 things that matter the most for GPE. So I'm going to go ahead and box that formula in, because again, that's very, very important. So this one's actually a little easier to calculate. So another way to write this is GPE equals M times G times H. And that's how we typically remember it in class. And that G is that acceleration due to gravity, which on Earth is that 9.8. So we would need to make sure we keep that in mind while we're working on this. So I'm going to work through one problem like I did for kinetic. So if my example has a mass falling from the height, so the mass I'm going to say is 82 kilograms, and it's falling from a height of 100 meters, let's say, we could calculate that. Now, if I increase the mass or I increase how high off the ground it is, it's going to make that GPE go up. So if you want a lot of GPE, you would want to go higher up on a hill, or you would want to increase the mass of the people sitting on the sled, so you would add more people. So that would be how you would do that. So again, GPE is M times G times H, so that's the first step. So number 1, we're going to plug it in. So we're going to write our GPE equals our mass of 82 times our gravity on Earth, which is 9.8, times the height, which is 100 meters above the ground. So 82 times 9.8 times 100. So this is my step 1, which is plug it in. Okay. Now we don't really need to square anything. So on this one, my step 2 would just be to use the G as the 9.8. So plug that 9.8 in for your G. And then my number 3 would be to calculate. So that would just be multiplying these 3 numbers together. So 82 times 9.8 times 100, once you plug that into your calculator, you would get 80,360 joules. Again, joules is our unit for energy. So we will box in our answer because that's what we do in class. So that would be part 3. Now, mechanical energy is actually a little bit different. So mechanical energy and mechanical potential energy are two different things. So we're going to go through that right now. So I'm going to flip the page. We're going to start